You don't have to be a Jedi to use the Force on light. I don't know about you guys, but I was totally blown away by the Star Wars 7 trailer, and there's so much I can geek out about right now, but I'm being told that I need to show at least a modicum of self-restraint, so I'll just say, squeeze! Okay, there's a lot we could cover here, but I want to concentrate on lightsabers. Is there any way we could ever make a real one? Now, if you remember our episode on holograms, you know we're not exactly experts on bossing light around. We can't tell a ray of light to just stop in midair. But some researchers at the Harvard-MIT Center for Ultra-Cold Atoms, which is awesome, have come up with a way to make massless photons, those particles of light, to behave as if they are atoms in a molecule. Now this is amazing because photons normally don't interact with each other at all. That's why you can turn on a couple of flashlights and pass the beams through each other without any interference. But the researchers found out that depending upon the medium you use, you can make things a little weird. Now, to start, they took some rubidium atoms in gas form and they supercooled them with a laser, which is also weird because don't lasers burn things? All right, let's back off a bit. Heat is essentially movement. The more a particle moves, the hotter it is. So imagine that you've got an atom coming right at you and you aim a laser at that atom. The photons in that laser are essentially massless, but they still have momentum, and that momentum slows down the oncoming atom. If you do this enough, the atom becomes essentially motionless and supercooled. All right, let's go back to those molecular photons. When a photon enters this gas of supercooled rubidium atoms, it transfers some of that momentum, that energy, to an atom. That slows down the photon, which means that light is traveling slower than the speed of light. This is just a good reminder that light's speed depends upon the medium through which it travels. Now, when that photon gets through that gas cloud, that energy rejoins the photon and everything is right with the universe. It's kind of like the way light travels through a glass of water, but on a bigger scale. But what happens if two photons enter the cloud? Here's where things get odd in an awesome way. You see, there's this weird effect called the Rydberg blockade, which states that if you excite an atom, you can't excite nearby atoms to that same degree. So when photon 1 enters the cloud and starts to excite rubidium atoms, photon 2 can't do the same thing. There's this push-pull relationship between the two photons. It's kind of like two lightsabers hitting each other, you know, go but it probably doesn't make that cool sound effect. So, does this mean I can finally build my own working lightsaber? Sadly, no. But there are some cool applications for this technology. One could be that photon interactions could become the basis of quantum computing. And I think my mind just melted a little bit. But beyond that, lead researcher Mikhail Lukin says we may one day be able to make three-dimensional objects like crystals out of pure light. Okay, I'm gonna need some time to process all this, but in the meantime, I have a question for all you guys out there. What science fiction gadget or gizmo or vehicle do you most want to get your hands on right now, and why? Let me know in the comments below. And remember, you will like this video. You will subscribe to our channel. And then make sure you check out these other awesome videos over here.